Okay, so I took the two functions and I wrote them. They said, tell me find the domain of g of x over f of x. So I put the g of x function on top and the f of x function on the bottom. And I didn't do any cleaning up because I wanted to just see what happens without any cleaning up. Because you really, maybe we could have in this one got rid of some, simplified a little bit, but those original from the original functions, those domain limitations stick. So um so x can't be, I can't divide by zero, or I can't take the square root of a negative number. So that tells me that x has to be at least zero, right? Zero or positive, right? So, but I can't divide by zero because that's in the denominator. Because if x was equal to zero, that would be one over, because the square root of zero is zero, so that's legit, but one over zero is undefined. So this, because the square is in the denominator, tells us the I domain has to be greater than zero. So then I looked at the denominator from f of x, and I know that I can't divide by zero there, right? Doesn't matter what's in top. I can't divide by zero in the denominator. So I solved that equation and I factored, I didn't factor it. I took the square root and plus or minus square root because you get two answers. The other way to have done that would have been to factor x squared minus 4. And I don't know if you remember from college algebra, that's the difference two squares, which factors to x plus 2, x minus 2. So positive 2, negative 2 show up again. So we've got these two situations we're going to deal with, and we've got the x is greater than 0 situation. And because x has to be bigger than 0, we're going to disregard the x can't equal negative 2 because that's not even in the mix. So all we've got to worry about is 0 being the lower limit, and then we got to skip over 2. So the domain has to be bigger than 2 because it can't, bigger than 0 because it can't include 0, because that would be division by 0 on the top. And I also have to skip over 2. So using intervals, it'll be from 0 to 2 or from 2 to infinity. Okay. Now for part B, it's telling me to find f of g of x. So what I did is I took, let's see, they're saying f of g of x. So g of f of x. So I'm going to drop f into g. So I'm going to take that function and drop it in for that x. Okay. So there's that. And then, of course, we can't, again, I can't divide by 0. I can't take the square root of a negative number. So I'm kind of doing the same work that I just did in the last problem, is finding out when does x squared minus 4 equal 0. And of course, that's at negative 2 and positive 2. And then I'm going to ask myself, well, that's more than just an x, so maybe there's something going on. So one way to do this is to draw a number line, put in your critical values, we'll call them. Those are the values I'm concerned about. Then test some numbers in the range and see if they're positive. So like negative 2, how about negative 10? Well, if I drop negative 10 into this equation here, won't that be 100 minus 4 is 96? I could take the square root of positive 96. That's okay. So that denominator is going to be positive there. I've got to skip over negative 2 because I know it's 0. So then I'm going to test a number in between negative 2 and 2. Well, 0 is a nice number to test. If I drop in 0, that'll be negative 4. I can't take the square root of negative 4. It's because it's a negative number, so that's out. And then I go on the other side of 2. Why not try positive 10 and see how we get the same result? Positive 10 would be 100. Minus 4 is 96. Square root 96 is okay. So the domain is from negative infinity until negative 2. Then we'll skip over negative 2 to positive 2, and then we'll go from 2 to infinity. Okay, so that's how you can do that. And then the very last question asks us to reverse it, find f of g of x. So I'm going to drop the g of x function into the f function. And I didn't bother cleaning it up. I just left it like this. I know x has to be bigger than 0. That's the same thing from before. So that limitation doesn't go away. Now, one thing I want to caution you about, some people think, oh, I can square it. Well, yeah, if I square 1 over the square root of x, don't I get 1 over x minus 4? And in that case, x could be negative there, right? That's not a problem. And so we could say x can't be equal to 0 in that case, which tells me I can go from negative infinity until 0, or from 0 to infinity. However, you wait a minute here. I'm going to graph this out in Desmos and show you why that doesn't work. So I had told Desmos that f of x was that, g of x was this, and I did the composite. I nested them, and look what we're seeing for domain. This graph is only graphing. It's not graphing on from when x is less than 0. It's only graphing on the right of 0, like that initial one I gave, not the one where it couldn't be negative. The reason this happens is because that original limitation of x can't be in a negative number, right? Or 0, it limits that. That doesn't disappear even if we do all this algebra on it. And one reason of that, what if I said, where's my board working? Here it is. What if I wanted to find f of g of negative 1? If I tried, so g is the inside function. So if I tried to find 1 over the square root of negative 1 first, that's undefined. I can't do that. So because it doesn't work there, it can't work in the composite function. So even though algebraically, if we were to simplify it, we get 1 over x minus 4, and we could drop in negative 1, because that original domain limitation was in place, we can't use it. Okay, so the best advice is when you're dealing with domains of composite functions is don't simplify. Leave them unsimplified, and that way you can still see those original limitations. Okay, a lot to this. I mean, it's not easy stuff. It takes some practice. I recommend you try some problems out of the textbook in chapter 4, and hopefully that helps. You know, it only comes with practice. All right, give me a yell if you need some help.